Like a whole PowerPoint to go through. And you may or may not get through the whole thing. Try. Uh, we'll see what happens. That's this 2B PowerPoint. But first, a little bit of an announcement. I conferred with my colleague across the way, Dr. Robbins, and it turns out that I originally thought we were going to have the exam for you guys on the 24th, but we're going to have it on October 1st. He tells me that in lab, that probably that week of the 20, whatever your lab is, the 23rd or the 24th, there's probably going to be a bones practical. And you're going to be absorbed with that. I know he's going to probably do open lab next week, a number of days. That means he'll be there a lot. Yes, ma'am. First. Okay. Number uno. And I'm giving the exam to all the classes that day. It makes it easy. It'll be no problem getting it in. I will, depending on what we cover today, and what we cover next week will sort of define what will be. I'm going to get to some of the cell, not all of the cell. There's no way I'm getting into the cell cycle or some aspects of organelles. I'd very much like to do the basic role of membrane and membrane proteins, and a little bit on the resting membrane potential of the cell, because it's so important. It builds on everything else that we're going to talk about. It may be movement across membranes. And that's basically where we're going to be. So without further ado, let me begin. So mark that down. Yeah, I mean, and it's a little different because I have to you're going to get this stuff in person, because I'm not going to be here on Friday for the other, about 100 students were in that Monday, Wednesday, and Friday crew. Your misfortune. You're stuck with me. Okay, here we go. We finished the PowerPoint A. I checked on the recording that I sent to you, and I hope that's working for you if you're looking at those and you can open them. I'm not expecting you to do me a favor. Just take the time to go over those a couple of times in your preparations. You have an ample, you've got 3 weeks to work on, to think about. And I know you got other stuff mostly going on. I would suspect those are the 2 big courses, the lab and the lecture, are ones that, I'm not saying the other courses aren't challenging, but I think there's a greater degree of work and emphasis they should probably put on these, to be fair. Voila. So what we're going to talk about this is all of it. Really, it's the foundation is biochemistry. With any good luck, we're going to get through all of them in the sense of carbohydrates and lipids and proteins and nucleic acids like RNA and DNA. If not, we'll pick up the rest. It's easy at the very end. So really what it is, this is us. We're made of chemicals. So biochemistry is all the chemicals that are associated with living matter and the reactions that they undergo. We classify them into inorganic and organic. For years, the definition of organic contains carbon. It's not exactly true. And even pointed out here in this PowerPoint that carbon dioxide and like carbon monoxide, which obviously have carbons in their name, are not organic, not in the least. Okay, so in order to be really, truly a better definition is carbon that is covalently bonded to other carbons and to hydrogen. So carbon to carbon and carbon to hydrogen bonds are really what define organic materials. Even if they're very, very simplistic, those are probably the minimum requirements that you have to have. If you start putting a bunch of funny chemicals on that, years ago I always told them about a thing where you had cleaning solutions, before we had more modern cleaning solutions that were not terribly toxic and fairly effective, they had a thing called carbon tetrachloride. Big skull and crossbones on it. Somebody got a stain on the couch or on the carpet. You got this stuff out. If you came anywhere near it, you could smell it. Heaven only knows what it would be like if it ever really got it in really close. Deadly poison. That's what it's got carbon, but with those 4 halogens, 4 chlorides on it. Bad stuff. Organic compounds. Basically, those are the 4 groups. We're going to look at those today, probably all. Carbohydrates, fats, proteins, and nucleic acids. You're going to see their composition is basically something they're going to point out here. With the exception of the fats, which are really better better known as lipids. Fats are solid at room temperature. Oils are liquid at room temperature. They come from different sources, other than those that are man-made, let's say. And to understand that they're basically small molecules, which are building blocks or repeat units, and large molecules, which are basically multiple units of the same thing or similar. The name we give to them in chemistry is monomers and polymers. Polymers, every day of your life, you've got in contact with polymers. The plastic of that cup from Starbucks, my iPod, my AirPods, your headsets, whatever you have, they've all got polymeric plastics that are associated with them. It just so happens they're not made of living materials. Surprisingly enough, those lightweight headphones that were so popular until we got the AirPods actually came from bacteria. Bacteria would basically interact with certain carbon-containing things, and the waste product was that same thing with like stuff to make